At 11:52 p.m., the city is quiet. Most people have turned off their lights. Most people have gone to bed. And most people, without thinking, will turn on a tap tomorrow morning. The water will come. It always does. But behind that certainty is a facility that never closes, never pauses, and never goes dark. A water treatment plant operates in shifts, 3 shifts, 24 hours. The incoming and outgoing water volumes do not change based on the clock. The city drinks, washes, flushes, and runs hot water, regardless of whether it is noon or 3 in the morning. Someone must always be watching. The night shift begins at midnight. The outgoing team hands over a clipboard, not a formality, but a record of every deviation, every pressure reading, every alarm that occurred in the last 8 hours. The incoming operator reads it carefully. Everything must be understood before anything can be touched. The plant draws raw water from a source, a river, a reservoir, a lake. Tonight, that source is carrying a slightly elevated turbidity reading. The water is cloudier than average, not dangerous, not unusual after last week's rain, but it requires a manual adjustment to the coagulant dosing system. The night operator has seen this before. He adjusts the feed rate by 4%. Coagulation is the first stage. Chemicals are added to the raw water to cause fine suspended particles to clump together. Those clumps, called floc, slowly sink to the bottom of large settling tanks. What rises to the surface is cleaner. What remains below gets removed. This process runs continuously, every hour of every day, without pause. At 1:17 a.m., one of the flow meters gives an unusual reading, not an alarm, just a number that is slightly off. The operator checks the secondary meter. They match. He logs it. He'll check it again at 2 o'clock. This is what most of the night shift looks like: watching, comparing, logging, deciding whether a deviation means something or nothing. The filtration hall sits at the center of the facility. 8 sand filter beds, each the size of a small swimming pool, work through the night removing what the settling tanks could not. Layers of fine sand and anthracite trap microscopic particles. The water passes through slowly. Gravity does much of the work. Patience does the rest. Every few hours, a filter bed must be backwashed. Water is pushed backwards through the sand to flush accumulated particles out. This takes about 15 minutes per bed. During that time, the bed is offline. The remaining beds absorb the load. The system is designed for this. Redundancy is built in, not because failure is expected, but because nothing can be left to chance. By 2 a.m., the plant has treated and dispatched over 40,000 cubic meters of water since the previous morning. That number does not pause for the night. Demand drops slightly. People are asleep. But the distribution network still requires pressure. Reservoirs and elevated tanks must remain filled. They are the buffer between the plant and the city. Chlorination happens near the end of the process. A controlled dose of chlorine is injected to eliminate any remaining microorganisms and to maintain a residual in the distribution pipes, a protective trace that travels with the water all the way to the tap. The dosing must be precise. Too little, and the water is unprotected. Too much, and it becomes objectionable. The target is a window measured in milligrams per liter. At 2:45 a.m., the lab technician on duty pulls a sample from the post-filtration line. She has done this every 2 hours since her shift began. pH, turbidity, chlorine residual, conductivity. She enters the results into a digital log that is time-stamped and unalterable. Regulators require this data. The city's health depends on it. The pump hall is the loudest room in the facility. 6 high-capacity pumps run continuously, each one pushing water through kilometers of underground pipe toward the distribution network. The noise is constant. The vibration is constant. Operators wear hearing protection when they enter. They check bearings, seal conditions, motor temperatures, reading the physical language of a machine that has no tolerance for neglect. Mehmet has worked the night shift here for 11 years. He doesn't think of it as unusual anymore. His body adjusted to the schedule after the first year. He sleeps from 8 a.m. to 3 p.m. His children are at school when he is awake. He is at work when they sleep. He does not describe this with bitterness. The city needs the water, he says. Somebody has to be here. At 3:30 a.m., an alarm activates in the control room. A turbidity sensor in the post-filtration line has exceeded its threshold. Not by much, but enough to trigger the alert. The operator pulls up the trend graph. The reading spiked 12 minutes ago and has since stabilized. He cross-references the raw water intake data. The coagulant adjustment made earlier is still working through the system. This is likely a lag, not a failure. He documents it. He waits. This is the tension built into every shift. Not catastrophe, just uncertainty. The difference between a reading that corrects itself and one that does not is a matter of time and attention. Night shift operators learn, over years, to distinguish between signals and noise. Most alarms are noise, but you cannot ignore them. You log them, check them, track them. The discipline is the system. By 4 a.m., the turbidity reading has normalized. The alarm is cleared and logged. No escalation required. The coagulant adjustment worked. The system absorbed the deviation on its own. The operator notes the time of resolution, 4:03 a.m. The log entry takes 30 seconds. The shift continues. The sludge generated by the settling process doesn't disappear. It accumulates in the base of the clarifier tanks and must be removed continuously via sludge pumps. Tonight, the sludge processing area runs without intervention. Automated valves, automated timers. But every hour, an operator walks the perimeter, checks the pump outlets, confirms the system is drawing correctly. Automation is trusted, but it is not left alone. Some of what happens at the treatment plant cannot be automated. A valve that vibrates differently from yesterday. A smell in one corridor that wasn't there last week. A sound from pump number 4 that is 1 pitch higher than usual. These are not measurable in a log. They are noticed by people who have been here long enough to know what normal sounds like. At 5 a.m., the city begins to stir. The first demand surge of the day arrives earlier than most people think. Night workers finishing shifts, early commuters, showers beginning in apartment blocks. The plant's outflow sensors register a quiet but measurable increase. The system is already responding. It was already prepared. The morning shift supervisor arrives at 6:45 a.m. She reads the night log before she removes her coat. 14 entries. 1 alarm, resolved at 4:03. 1 coagulant adjustment at 12:18. 1 backwash sequence on filter bed 3. She asks 2 questions. She nods. The night has been managed. The system has held. At 7:15 a.m., the night operators leave. They pass through the exit quietly. No ceremony. No announcement. The facility does not pause to acknowledge the shift change. It cannot. The pumps do not care about the calendar. The water does not wait for gratitude. The system simply continues, carried now by a different set of hands. The facility covers over 4 hectares. Most of it is hidden from public view. Walls, fences, locked gates. The infrastructure that serves a city does not need to be seen. It needs to be reliable. And reliability is built slowly, through maintenance cycles and personnel rotations and the accumulation of small, correct decisions made by people working through the night. The city does not see the facility. It does not need to. The arrangement depends on that invisibility. People move through their days, their taps, their showers, their kettles, their workplaces and hospitals, and none of it requires awareness of the pressure behind the pipe or the shift log from the previous night. That is by design. Every treatment plant has a laboratory that processes hundreds of water samples per week. Upstream samples, downstream samples, mid-process checks, final discharge tests, each one recorded, each one traceable. If something changes in the water, the laboratory sees it first, sometimes before the sensors do. In most facilities, a contamination alert is the scenario that everyone trains for, but hopes never arrives. Protocols are updated annually, response times are drilled, isolation valves mapped, communication chains maintained. The probability is low, but the consequence is high. So the preparation is permanent. The distribution network begins where the plant ends. Treated water enters a pressurized pipe network that spans hundreds of kilometers beneath the city streets. Maintenance of that network belongs to a different team, a different set of shifts, a different facility entirely. But it begins here, with the water that left this plant in the last hour. What makes a treatment plant work is not a single technology. It is the alignment of dozens of systems operating in sequence, each one dependent on the one before. If intake is compromised, pre-treatment suffers. If coagulation is off, filtration compensates, but only to a point. If filtration is overloaded, disinfection carries more burden. Each stage is a safeguard for the stage before it, and a risk to the stage after it. During the summer months, the plant operates near its upper capacity. Demand peaks, reservoir levels drop faster. The incoming water temperature rises, which affects coagulation chemistry. Algal growth in source water increases, adding a biological parameter to an already complex system. Summer is when the plant works hardest. Summer is also when the fewest people think about where their water comes from. Maintenance on the facility's mechanical systems follows a schedule that runs independently of production. Pumps are serviced on rotating cycles. Valves are tested. Control panels are inspected. Pipe insulation is checked. A plant that is always running must also always be maintained. The two imperatives run in parallel, managed by the same team, across the same shifts. Emergency power is not a luxury at this facility. It is infrastructure. 2 diesel generators sit in a dedicated building at the edge of the plant. They are tested monthly. If grid power fails, they are designed to come online in under 10 seconds. In 10 seconds, the pumps cannot stop. In 10 seconds, the distribution pressure cannot drop. The city does not feel a grid failure, not because it didn't happen, but because the preparation was complete. At 8 a.m., school buses leave depots. Cafeterias begin preparing lunch. Office kitchens fill with the sound of running taps. Hospitals begin elective procedures. None of this can function without water. All of it takes for granted that water will be there. The treatment plant, running through a night that no one witnessed, made that assumption correct. The people who work these shifts do not expect recognition. Most of them understand that invisibility is the definition of success in their field. The plant is not noticed when it is working correctly. It is only noticed when something goes wrong. And for 11 years on Mehmet's shift, nothing has gone wrong. That is not luck. That is work. The treatment processes themselves are a century old in concept. Coagulation, settling, filtration, disinfection. The chemistry has been refined. The automation has advanced. The monitoring is now digital, continuous, and archived. But the logic is the same. Take what nature provides, remove what threatens, and return it ready for use. Elegant in principle, demanding in execution. Water quality monitoring extends beyond the facility perimeter. Sampling points exist throughout the distribution network, at fire hydrants, at municipal taps, at hospitals. Field teams pull samples on scheduled routes. Results feed back into the plant's operational decisions. The facility is not a closed system. It is the beginning of a chain that extends all the way to every fixture in every building in the city. In the event of an incident at the source, a chemical spill upstream, an unusual bloom, unexpected industrial discharge, the intake can be isolated. The facility has storage capacity. It can operate on stored raw water for a limited period while the source is assessed. This has happened before, and each time the city did not know. The plant's environmental responsibilities extend to what it discharges as well as what it treats. Backwash water, sludge from clarifiers, chemicals used in the process. All of it must be handled, processed, and discharged within permitted limits. There is an outflow as well as an inflow. The facility exists within a regulated ecology as well as a regulated infrastructure. Training at a water treatment facility is not a one-time event. Operators undergo recertification. New chemical handling protocols are introduced. Emergency scenarios are rehearsed. Regulatory changes require updated procedures. The system does not stand still, and neither do the people who run it. Competence here is not assumed. It is renewed. By mid-morning, the day shift is in full operation. The pace changes. More personnel on site. Maintenance crews active. Scheduled deliveries of chemicals arriving. Supervisory walkdowns in progress. The facility is more visible to itself during daylight hours. But the process underneath runs the same as it did at 3 a.m., indifferent to the clock, committed only to continuity. The afternoon shift begins at 4 p.m. By now, the day's demand peak has passed. Consumption tapers from the midday high. The incoming team reviews the data, accepts the logbook, inherits the system. And the cycle continues. 3 shifts, 3 handovers. Every day. Every week. Every year. There is a particular quietness to facilities like this. Not silence. There is always the sound of water moving, pumps running, pipes under pressure. But a quietness of purpose. The work here is not performed for an audience. It is performed for an outcome. The outcome is a city that wakes up tomorrow and turns on a tap and does not notice. The next morning, the city wakes again. Taps opened, showers running, coffees made, water consumed without thought, without gratitude, without awareness. And this is exactly as intended. The system has done its job when it is most invisible. 365 days a year, the night shift begins at midnight. 365 times, the logbook opens on a new page. 365 times, the outgoing team hands over the clipboard to someone who will stay awake while the city sleeps. The system does not celebrate this continuity. It requires it. What is a water treatment plant? It is not a building. It is not a machine. It is a decision, made by a city once, that its water would be safe, and then the daily act of keeping that decision true. By the pump operator who knows his pumps by sound. By the lab technician who pulls samples at 2:45 a.m. By the supervisor who reads the log before she takes her coat off. The decision made. The decision maintained. The shift ends. The plant continues. Somewhere in the city, a tap opens. Water flows. And the night, the log entries, the adjustments, the quiet corrections, the watchful hours, all of it dissolves into the ordinary, as it should, as it was designed to. Under this video, there's a subscribe button. It's a small action, but it helps reveal the systems most people never notice. If you're curious about how everyday life actually functions, the shifts, the logistics, the invisible labor, consider subscribing. And tell us in the comments, Where are you watching from? Have you ever worked behind the scenes of a system like this?